All right, so welcome to this video. Today we'll be looking at math tutorial sheet 1 questions. Okay, so this tutorial sheet has about 23 questions, and we are going to answer all the questions in this tutorial sheet. Okay, so by the end of you watching all these videos, you should be comfortable with the topics that are here and be able to answer questions from past quizzes, past tests, as well as the past final exam. So as we can see, the concepts that are contained here, we have set theory. Okay, you can see there are some definitions there. And then we have roster form. Okay, we have set builder notation. We move on to power sets. Okay, and then simplifying set expressions, proving and stating set laws such as the De Morgan's laws. You can see there all these questions will be solved. Okay, and the full videos will be available. Okay, you can see here we are using set operation to just combine sets. We'll talk about set interval notation. You can see from question 11, 12, 13, that's several set interval notation. And then now we'll look at how can we apply this set theory, okay, to real life situations, maybe at the hospital and the like. Okay, real life medical situations. So that's where question number 14, question 15 comes in. Okay, then from there, we'll move to what we call as the irrational numbers. Okay, how do we express irrational numbers? How do we express rational numbers? We'll deal with SADs and rationalization. All these questions will be solved, and all these videos will be available for you. All right, so let's begin our uh, revision. All right, so welcome to this video. Today we'll be looking at defining terms, okay, that are used in set theory. So we start with what is called as a subset. Okay, so what is a subset? So let's define it. So part A, we are going to say a set A, okay, is a subset of another set B if every element of A is also found in set B. Okay, that is A is a subset of B. Okay, sometimes you can also write it as A is a subset of B. Okay, so a set A is called as a subset of another set, let's say B, if every element of this set A is also found in the set B. So an example can be set A has the elements 1, 2, okay, and then this set B has the elements 1, 2, 3, 4. Okay, so you see that every element in this set A is actually a part of B. So B has more elements than this one, and all the elements in A are a part of B. So we are going to say A is a subset of B, because every element here, I can also find it in the set B. So that is what we call as a subset. Okay, so you can pause the video, read through the definition until you understand it. Okay, part B says define equal sets. Okay, so I'm going to write the definition here. Two sets, okay, are equal if, okay, they contain exactly, okay, if they contain exactly the same elements. Okay, if they contain exactly the same elements, then we are going to say that they are equal. But this is a lame definition, okay? Anyone can understand. So now in math, we are going to be defining equal sets in the following way. Okay, we are going to say, I'm going to say sets A and B are equal, okay, if and only if A is a subset of B. We know what a subset is, we've defined it, and B is a subset of A. Okay, so two sets, A and B, can only be equal if they are subsets of each other. So if A is a subset of B and B is a subset of A, okay, then we're going to conclude that those two sets are actually equal. All right, so you can brainstorm about that. You can pause the video, read through the definition, think about it until you understand. Otherwise, I'm going to erase this and talk about part C. So part C says define the union of sets. Okay, so the union of two sets is the set containing all elements that are in the sets that you are considering, that are in the sets under consideration. Okay, I'm sure we've had the union since grade 7, so there's nothing much to explain there. So if, for example, I have A has 1 and 2, and B has 3, okay, the set A union B will just be a combination of all of these, making sure that those that repeat are not written twice. So that is the union. And then the intersection of the set, okay, it will be more like the same. So the intersection of the set, okay, I'm going to say the intersection of two sets is just the set containing elements that are common to both elements. Okay, so if A is 1 and 2, and then B is 2 and 3, then I'm going to conclude that my A intersection B is equals to 2. So the set that contains elements that are common to both sets that are under consideration is what we call as the intersection. Okay, what about the complement of a set? Okay, so that is part A. So part E, we're going to say the complement, okay, of a set A is the set of all elements in the universal set that are not in A. Okay, the complement of set A is the set of all elements that are in the universal set, but they are not in that particular set. So a set that contains the elements that are not in the set under consideration is what we are calling as the complement. Okay, what about the set difference? This is part F. So the set difference, A minus B, for example, is just the set that is the set of elements that are in A but are not in B. Okay, that's the definition. The set difference A minus B is the set of elements that are in the first set but not in the second set. So if I wrote C minus D, this would just be the elements that are in C but not in D. If I wrote F minus, E minus F, it will be the elements that are in E but not in set what? Set F. Okay, so how do you find it? For example, A have 1, 2, 3, 4. And then B, let's say I have 3, 4, and then 5. So now A minus B, remember the definition that we said? We said elements that are in A but not found in B. So when I look at these elements here, okay, which elements, okay, are just in A and are not found in A? Of these elements that are in A, which one are just in A and not found in the set B? You see that 1 is just in A, so it will be in the difference. 2 will also be in A, it will be in the difference. But these 3 and 4 are also in set B, so I can't include them in this difference here. So I'm just going to say we have 1 and what? 2. Okay, so that's the set difference. Symmetric difference of sets. Okay, they've even given us representation there. So what are they? Or what is the symmetric difference of sets written like this? Okay, so I'm just going to say the definition. So the symmetric difference of two sets, okay, A and B. Um, how should I say? Okay, let me say it like this. The symmetric difference of two sets, okay, is the set of elements that are in A or B, but not in both. That's the definition. The sets of elements that are in A or B, but not in both. Okay, so for example, A, 1, 2, 3. B, 3, 4, 5. So I said now A, symmetric difference with B. This is a set of all elements that are in A or B, but not in both. So meaning we just have to cancel out whatever is in the intersection. So what is in the intersection here is 3. 3 is in both, so we cancel it out. So 1 and 2, they're in A, and then 4 and 5 are in B. So the set that contains elements either in A or B, but not in both. So we just cancel out those elements that are appearing in both the sets. Okay, what about the power set now? So the power set, okay, is the set of all possible subsets of a particular set. That's all. Okay, a set that contains all the possible subsets of a particular set, that's what we call as the power set. Okay, all right, and then what is an infinite and uh, finite set? So infinite sets, okay, so infinite set, this is a set, okay, whose elements are uncountable. Okay, this is a set that contains elements that you cannot count. So for example, the set of natural numbers, it has 1, 2, 3, 4, 5, and you continue going until forever. Okay, so this set here is an infinite set because the elements that are here, you can't count them. Okay, they are infinity. If you start counting now until the day Jesus will come, you will still be counting. Okay, what about finite sets? So finite set, this is a set whose elements are countable. So for example, A has 1, 2, and then 3. So you can count 1, 2, 3. So this is finite sets. Okay, this is finite sets. Okay, so those are the definitions. And then the last one is the cardinality. So cardinality simply means the number of elements in a particular set. Okay, so the number of elements in a particular set, that's what we call as the cardinality of sets. All right, so we'll look at the concept of roster and set builder notation. Of course, before we solve any questions on those concepts, we need to define what is the roster form, okay, and what is involved in the roster form. And we also have to define what is the set builder notation and what is involved in the set builder notation. Okay, so now when you talk about sets, okay, when you talk about sets, there are a lot of ways in which you can represent sets, but the most important ones that we're going to be using in this course are one, the roster form. Okay, we're going to use the roster form to represent a set. And number two, we're going to use what we call as set builder, okay, set builder notation. So these are very key important concepts that you must know um, in this course. Okay, we're going to look at the roster form and the set builder notation. So these two are some of the ways in which we actually represent sets. Okay, so I'm going to write two expressions here, and then I'm going to ask you a question. So the first one, I'm going to represent a set like this. I'm going to say, okay, set A is actually, okay, being represented as 2, 4, 6, and then I'll end at 8. Okay, that is my set A. And then I'll also write another set. We can call it B. Okay, and for this set B, I'm going to represent it in this way. X, okay, and then X is an even number. Okay, X is an even number. Um, and this same X, okay, is actually less than 10. So X is an even number and it's less than 10. So you can see those two descriptions that I've written for these two sets, A and B. Okay, so now the first one here is what we call as the roster form. Okay, so in the roster form of representing set, you are simply listing all the elements that are going to belong to that particular set inside what we call as the carry brackets. Okay, so let me write the word here, carry brackets. So the carry brackets are these guys here that you can see, these two more brackets here. Okay, are what we call as the carry brackets. So you list all the elements that are going to be in that particular set. In this case, we're saying set A contains 2, 3, 6, 8. So we have listed all the elements that are in that particular set, and we have used curly brackets. Then we're going to call that type of representation as the roster form. Okay, and then the second representation that I wrote is this one for set B. Okay, so you can see that here there are curly brackets there, these ones at the end and the beginning. Okay, and then now there's a notation that I want you guys to know. Okay, so you've seen this more like a line here, this guy here, this guy. Okay, it's actually a symbol in math that means such that. Okay, it means such that, and in some books or sometimes you can actually represent it as a full colony like this. Okay, so full colony like that or a straight line like that, they mean such that. Okay, they mean such that. Okay, and then this here is just describing what you're going to find in this particular set, which we're saying what? B. So whenever you see such a notation here, it is read as, okay, it is read as set B. Maybe I should be writing it so that it's easier for you to remember. So you say set B, this B, set B is a set of all x's, okay? So we're saying set B is a set because there are these curly brackets outside. Okay, so no wonder I'm saying set B is a set of all, this X here means of all X's. Okay, set B is a set of all X's, and then I have this symbol that the one that will read as such that. Okay, set B is a set of all X's such that X is an even number, and that even number should be less than what? 10. That's how we read the set builder notation. Okay, so this expression on B here, this is the set builder notation, and it is read as set B is a set of all x's such that, okay, x is an even number, and this x is actually less than 10. Okay, so you can see that for part B, we are not listing the exact elements that are there, but we are describing a rule that would tell us, okay, this particular number should be in this particular set, okay? Or we're just giving a general description of whatever you're going to be to find in that what? In that particular what? Set. So for the set builder notation, you describe what is going to be in that set, okay, using words, using formulas, and so on and so forth. Then for the roster form, you actually list all the elements that will be in that particular set, and you enclose them in what we call as the curly brackets. Okay, so any questions there? Any questions that you may have there? Okay, so if there are no question, you can now see that this set A is actually just the same as set B. This is just in roster form, and this is just in what? Set builder notation. Because when you go to this set B, you can see I'm saying X is an even number, and that number should be less than 10. So what you have to know here is what even numbers are. Okay, so what are even numbers? Even numbers are numbers that can be divided by 2 without leaving any remainder. So meaning 2, 4, 6, 8, 10, 12, 14, just like that. Those are even numbers. But here there's another limit that tells us that this even number that I should put in this set B should be less than 10. So how many even numbers are less than 10? They're the ones that you're going to list. So 2 is an even number, it's less than 10. 4 it's an even number. 6 is an even number. 8 is an even number. I can't write 10 here because they said this even number should be less than 10. So I just end there like that. And you can see that this here is the exact set that was in part A. Okay, so in set A, set B, these are equal, but the other one shows in roster form. The other one shows in what? In set builder notation. All right, so I've explained what these things are. Let's now try to answer questions from the tutorial sheet. Okay, so this here is our first question that we are going to answer. So this question says, write the following sets in roster form. So they're simply telling you lists. Okay, list all the elements that are going to be in that particular set. And all these sets that we've been given here have been given in set builder notation. So meaning we have to interpret what they are telling us or what they're describing, and then now we put it in the set what? A. So for the first one, which is part A, they're saying set A is a set of all x's, okay, such that, okay, x is a prime number, but this prime number should be between 20 and 50. Okay, should be between 20 and 50. Okay, so I think I made like a small error here. Okay, so this one here should be a semicolon and not a full colon. Okay, so this one here should be a semicolon, not a full colon. So meaning like a full stop and like a comma. So that is semicolon. Okay, so set A is a set of all x's, okay, such that x is a prime number, and this prime number is between 20 and 50. So what you have to know here is what prime numbers are. Okay, so anyone who can help us, what are prime numbers? Anyone? You've learned this at secondary level. What did we used to say? What are prime numbers, guys?
Number that can be divided by 1 in itself.
Exactly. Okay, so prime numbers are numbers that only have two factors. By factors, we mean the numbers that can go into that number without leaving a remainder. So prime numbers, okay, are numbers with only two factors, itself and 1. Those are prime numbers. Okay, so if you are to list the prime numbers, okay, it would be 2 only has two factors. Only 2 and 1 can go into 2 without leaving a remainder. 3 is the same. Okay, 5 is the same. 7 is the same. 9, no. 9 is not a prime number because 9 can be divided by 9 itself, can be divided by 3, and it can be divided by 1. So it's not a prime number. Okay, so 2, 3, 5, 7, 11. Okay, 13, 15, 14, those are not prime numbers. Okay, 16 is not a prime number. 17 is a prime number. 19 is a prime number. 20 is not. 21 is not. 23 is a prime number. Okay, from 23, 24 is not a prime number. 25 is not. 26 is not. 27 is not. 28 is not. From 23, we go to 29. Okay, and then from 29 we go to 31, we go to 37, we go to 41, we go to 43. Okay, we can check all the numbers in between. 47, 48 is not a prime number. 49 is not a prime number. Okay, is 50 a prime number? No. 53, it's not a prime number. In fact, here they said between 20 and 50, so I can end on 47 here. Okay, I can end on 47. So these here are the prime numbers, okay? But they said in this set A, you should only include prime numbers that are between 20 and 50. So you can see that the prime numbers that are between 20 and 50 are 23, 29, 31, 37, 41, 43, 47. So I'm going to write them there as a set. So this will just be 23, 29, 31, 37, 41, 43, and then 47. So this here will be the set that is going to be in roster form for this description that we've been given on part A. Okay, so any questions there? Okay, so that is the answer on part A. We can look at part B. Okay, so don't be shy. If you have a question, please just unmute yourself and then you can ask. Okay, anyway,
Yes.
you have a question?
Yes. How about 27?
27 is not a prime number because 27 can be divided by 1, can be divided by 9, can be divided by 3, it can be divided by 27 itself. So the factors are more than 2. So it's not a prime number.
Okay, thanks.
Okay. Okay, let's check what the part B is saying. So part B is saying P is a set of OXs, okay, such that X, so they've written X is a member of Z and then they've written plus like that, okay? So in sets, whenever you see Z, Z represents what we call as integers, okay? So integers are those numbers that you see on the number line. So 0, -1, -2, 1, 2, okay? These are what we call as integers. So for the integers, okay, there are those that are negative and those that are positive. So when you just see the symbol like that, okay, in fact, it's usually having like a doubled line there like that, okay? So this symbol here represents integers, okay? But now this symbol for integers, when they write a positive on top, it means they are only talking about positive integers. And positive integers are the same as the natural numbers. Okay, this is a symbol for natural number. Should write it like this. So this one, double line, and then like that. So these are natural numbers. These are positive integers. So positive integers, natural numbers, they're the same thing. I remember the other week I sent the video on sets of numbers, different numbers that you have to know. Okay, what are natural numbers? What are integers? All those things I explained in that video. So now the integers, the positive ones are the same as natural numbers. So natural numbers, okay, or positive integers just start at 1, 2, 3, 4, until forever, wherever you're going to end counting. So they are also called as counting numbers. Okay, so positive integers, or what we call as natural numbers, are just counting numbers, something that you can use to count. So we start counting from 1. We never start counting from 0. Okay, so counting numbers start at 1, 2, 3, 4, just like that. Okay, and for this type of numbers, there are no fractions that are involved, and there are no decimal numbers that are involved. They're just whole numbers that are positive. Okay, so this is what we've been told here. We've been told that this set P, okay, is a set of OXs such that X is a positive integer, okay, which is just the same as a natural number. And this X is actually less than or equal to what? To 12. So meaning that the numbers that are going to be in this set P, okay, will just be the numbers from 1 to 12. That's all. Okay, so you're going to list them 1, 2, 3, 4, 5, 6, 7, should write 8 here, 9, 10, 11, and then the 12. So these ones here will be the elements that will be present in the set what? P. Okay, so we've listed that set now. All right, so any questions there, guys? Okay, so one thing that you should take note here is that for you to answer questions on roster and set video notation, you have to know the different types of numbers that we have. Okay, and I shared that video If you didn't see it, you can inbox me after the class. I'll share it to you. Okay. That video talks about sets of numbers. So we have to describe different set of numbers. But for most of these questions here, we'll just be talking about the natural numbers. Okay. So that was part B. Let's look at part C. Part C is very simple because they have given us a formula. So they're saying this set E, okay, is a set of all x's such that x, okay, such that x is equals to this formula, n plus 5 divided by 2n, okay? And this n is actually a natural number, and this natural number should be greater than or equals to what? To 5. Okay, so now the set of natural numbers, as I said, just these are just counting numbers. So it starts at 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. This is a set of natural numbers. Okay, so now here we've been told that x is equals to this particular formula. The n is a natural number and the n is greater than or equal to 5. So meaning the values of n that I'll start picking here should start at 5, 6, 7, 8, just like that. Okay, because here they said n is greater than or equals to 5. So meaning 5 or something that is more than 5. Okay, so to find the elements that are here, that is going to be what we call as an infinite set. So an infinite set meaning you can't list all the elements that will be there, because here I can't list all the n's, okay, that I can use here, because it's 5, 6, 7, and so on and so forth, because here they just said greater than or equal to. Okay, so this is going to be an infinite set. So I'm going to say, okay, the first member to be in this particular set will just be x is equals to when the n is 5. So when the n is 5, here I'll put 5 plus 5 divided by 2, 5. So this here will just be equals to 10 on top, and then down it will be what? 10 as well. So I can write it the way it is. So 10 over 10, comma. What about when the n is equals to the next one, which is 6? It will be 6 plus 5, and then down there it will be 2 multiplied by 6, and that will just be 11 over 12. So I'll write 11 over 12, comma. What if my n is 7? You just continue like that. Okay, so if my n is 7, then it will be x is equals to 7 plus
Just
5.
a question.
Okay, you can ask the question.
So when we're doing this element out here, we don't apply the Bodmer's rule and stuff,
The board must rule. Like on which part
like
exactly?
operations,
Oh,
operations
operations.
rule. Yes, where maybe we like divide first and multiply and stuff like that.
Okay, so you can apply them. It depends with the scenario. But this scenario here
Mm-hmm.
is a very simple scenario. So first solve whatever
Mm-hmm.
is going to be in the numerator. No wonder here I was saying we
Oh,
add whatever was in the denominator. I get 10, right?
okay.
And then I multiply
Okay.
whatever was down there. I also get 10.
Okay. All
Mhm.
right.
So we're going to do the same here. So it will be 7 plus the 5. So this gives me 12. And then 2 divided by this, I'll get 14. Okay, so I'll put here 12 over 14. So now this will go on until forever, okay, because the values of n that you can select are actually not countable, because here I'm still going like that. So meaning the value that I'll get here will still continue to go until wherever they will go. So this here is going to be our set E when we actually write it in roster form. Okay, so if there are any questions, please ask before we move to the next one. Okay, so let's do a similar question on part D, because there is also a formula and the values of n that we should use. All right, so thank you so much for watching that video. If you'd like to access the full solutions to that paper, you are welcome to access them at discretelearning.com. Okay, so also know that Discrete Learning Institute, okay, offers supplementary lessons to all the 4 first year courses. Okay, so either it be NS, pre-med, or A-levels biology, we have it on our website. Okay, we have physics, we have chemistry, and we have mathematics. Okay, so both for semester 1 and semester 2, we have all those courses on our website. So for any of the courses that you decide to register for here, okay, in case you're having some academic challenges there and there, okay, you are going to access a full quiz and tests solutions. Okay, so like the quizzes for the past intakes, you're going to access full videos to them and just learn how to actually answer the questions. You're going to access full tutorial sheet solutions. Okay, so all those tutorial sheet that has a lot of questions, we have solved them as Discrete Learning Institute, and you'll be able to access them on the website, okay, as well as on our mobile app. So you just go to your Play Store, okay, or to your Apple Store, you search Discrete Learning Institute, and then you download that app, you'll be able to actually use this. Okay, we also have solutions to final exam papers. Okay, so as you're preparing for your exam, your tests and the quizzes, it's also important to go through the past papers. So we have video solutions for questions from past exam papers. Okay. In addition to that, we also have lessons to all the topics. Okay, so all the topics, in case you miss a lesson at the university, okay, or miss a lecture, you miss a tutorial, we have all the topics available on the website, and you can access them at any particular time, even in your blankets. Okay, we also have full assignment solutions, which you can find on the website. Okay, and once you register, you also be allowed to consult from us. Okay, so meaning that if there's something that you don't understand in class, you can simply contact us and we'll be able to help you understand. Okay, plus number 7, this is a bonus. You will be able to attend live weekly classes. Okay, so these live weekly classes are interactive, okay, and we'll get to interact with you, okay, in real time. You ask the questions, we explain. It's just a nice lesson setup that we have, okay? So you'll be able to attend those weekly live classes, and it will make your learning easier. Okay, so for those who've never seen the website, okay, and want to actually subscribe right now, you can simply just open any browser. Okay, so I'll open Chrome and then type in discretelearning.com. So punch this, okay, it takes you to the website. So this is the website here, and you can see there are a lot of courses here. Okay, so depending on the level where you are, we have these filters on top. Okay, you can even check here where there's a filter like free courses. So there are free study materials that you can use, like the past papers, past tutorial sheets, notes and the like. You can go there and then you're going to find them. So if, for example, you're in first year, just click here, first year courses. Okay, you click there and then it will take you to the first year courses only. Okay, so these are the first year courses that we have. Okay, so you can subscribe for any course that you feel you need help with. Okay, and if you subscribe for any of these courses, you're going to find the tutorial sheets, the past papers, as well as the topic lessons. So if you want to subscribe, okay, once you log into the website, okay, some of you don't have an account, it will ask you to create the account. Once you create the account, you'll be able to log in. Just click here where it's written subscribe to course. So click there, okay, and then it will take you to the part where you can make the payment and then be able to access the course. So even here there are filters, okay, in case you are lost, just click if you're in first year courses, okay. So the first year courses will appear here and you can actually subscribe for any of them. So just select them. Once you select them, you can also choose the duration, okay, by clicking this arrow, which is pointing downwards. So click there and you can see different periods have different amounts. Okay, so if you want to subscribe for a week, there's a price for that. 2 weeks, 3 weeks, 1 month, 2 months, even 2 years in advance, you can subscribe. Okay, so once you select there, you proceed to the payment. A prompt is going to come on your phone to put the password and the like. You put subscribe, then you have access to the course. Okay, so this can be done by you yourself. Okay, you don't need anyone to do this for you. You all have phones and the like, so just subscribe and say goodbye to your academic pressures. Okay, so if you want a full guide, you can kindly check the link in the description below here. Okay, it's going to give you a video that shows you how to make an account on our website and how to register, although I've showed you again here. Okay, and then you're also going to find a link to our website and the link to our mobile app. Okay, so subscribe now and say bye to your academic challenges. Okay, so for those who would like to contact me, my number is 0779 96 40 and then 10. So that is Tutor Pro Solutions. All right, so thank you so much for watching. This has been Tutor Pro Solutions. Until next time, always there for you.